Welcome back, everybody, and welcome back to NMRA. Our next presenter's passion is to stop the process of just building and start a better process of engineering the infrastructure we use to display our models. In his last clinic was about the approach used to define the process of engineering rather than just building. He uses today's modern techniques to build and retrofit the most simplistic of model railroad benchwork. In today's presentation, we will be talking about culverts, tunnels, and more. Please welcome Jeff Rykiel.
Hi guys. So this is the video that you're about to see is part 3 of the Module 101 series. So let's go ahead and roll that video now, and then we'll come back and we'll deal with your questions. Go ahead and roll the video.
3D objects for model railroading is a lot of fun. Learning how to create them with 3D computer.
Greetings and welcome to part 3 of our modular system. As you can see, we now have a new module that we need to deal with. In this case, we're going to be doing some tunnels and some culverts. A couple things we want to look at here is we want to make sure that we go through the process of doing it correctly while still maintaining the strength of the entire system. We'll show you how to make the cutouts for your tunnels in 2 different ways. We'll show you how to use the story stick like we did in our elevation modules to use this and keep the same elevation on both areas. We'll show you how to make sure you maintain the strength of this culvert, and we'll show you what happens after we put in the sub-roadbed here and how to do it. We'll also show you how to connect it to your sister module for added strength and durability. For right now, let me show you how I built this. Let's get started. Okay, I brought out all the material I'm going to need to build the next module in the set. In this case, the sister module to our current elevated module. And as you can see, the pieces are a lot wider, they're a lot heavier, and in this case, the weight's going to play a part, but we're going to strip most of that away. There are a certain number of conditions or limitations I have to deal with. So you might think that you might just go ahead and start slapping the boxes together and cutting your terrain, but there's a couple of things that we need to deal with. First of all, the sister module. Well, this is what we're going to be butting up against, so we're going to have some conditions associated with this. The first one is the terrain. Obviously, the terrain on the corner side here is going to be a little bit different. We're going to have to deal with that. So what we want to do is make a mirrored set, and that's going to be our starting point. The second thing is the track plan. So the track plan is a given. So if you're part of a club, you're going to have your standard track plan, probably outside and inside main lines, and then whatever additional pieces or additional rail spurs that you might have, you're going to have to deal with that. So in our case, we have another condition because this particular spur is actually still on an elevation. It means it's still going up, so we're going to have to deal with that as well. And we'll show you how to deal with that shortly. The next thing you're going to have to deal with is called the track line. Since we're going to be making some terrain out of this particular module where the terrain is actually going to go under the track line, that creates a weak point. We'll show you how to deal with that. Also, we're going to have to deal with our tunnels and our heights. The other thing that we're going to have to deal with is how we're going to transport this. Now let me kind of clarify this. The taller it gets, which is what we're going to be doing here, depending on how you're transporting it, will actually determine how tall you want to make it. If you want to make it 24, 25 inches tall, that's completely up to you. But our transport cases limit us to a 16-inch height from the bottom of the module to the top of the terrain. So we're going to have to take that into consideration. Also, because you're going to be dealing with a lot more wood here, you're going to be dealing with a lot more weight. So when you go to a show or you're going to be setting this up, you're going to have to deal with the extra weight. So we'll show you how to deal at least with some of those. Other things that are also associated with our conditions are if we're going to use backdrops, how you're going to wire it, your electronics, if there's any electronics on the inside, and maintenance. Maintenance plays a factor here because now we have tunnels. How do you get to that in case there's a derailment? How do you get to that in case you need to do track cleaning and so forth? And then obviously the last piece of the puzzle is what happens on the other end. If you're part of a club, do you have to deal with those conditions as well, such as a 5 and 7-inch main line? If those are a requirement, you'll have to account for those. So before we get started, we're going to show you what we did with this and show you those conditions specifically, starting with the front and the elevations. So let me set up the camera a little bit differently and we'll go from there. if you remember when we were building the sister module here originally, we had a couple of elevations that we had to deal with. The first elevation is literally listed in black, and I've taken the time to create the lines for you so that you can show you better. The upper elevation is listed in red, so that actually shows what's going on here. So our first elevation is our black one, and our red elevation is for our spur module. And every location of where it intersects is how I determine where to make the cuts for our elevation. So that's condition 1. Now you see that the elevation does not level out, so when we get to this point here, we just can't go straight. We're actually going to have to curve it back to where it's at a level elevation. We'll actually just use the same reference line as we get there. The second piece is where we're going to start here. This is our first reference point. So we're going to start at this point here, and we're going to make our sister connection point, and then we're going to start to build off of that. So we're going to reset the camera and show you how we get started here. So let me move these out of the way just for a second. So we're going to get started working on our first reference face. Now, I get a lot of questions about these block corners. Since these block corners are literally what's going to be used to generate our 90-degree angles, I get a lot of questions on how to make them. So before we kind of get started on this, let me show you how I make these. Okay, let me show you how I make the blocks for use on our end corners of our modules. Block typically going to come out like this, but how I make them is pretty independent. It's pretty simple actually. First, when you buy lumber at the home center or whatever, it's going to come probably with a color on the bottom of it. It just tells you what type it is, what color it is. It's to protect the ends basically so that it doesn't start to split. So they come in long sections. They could be 6 foot, 8 foot, 12 foot in some cases. And when I use them for a project, I'll use them for the other project first, and I keep the cutoffs, and that's what you see here. Now these cutoffs come in a variety of lengths, doesn't matter what they are. Anything shorter than probably 3 or 4 inches, you probably want to get rid of. But all of these others, which may or may not be useful, I'm going to use. Okay? And I'll try to match them up as close as to what they can. And in some cases, I might double or triple them up. Or, in this case, I can do something like this. Now, we know that they have to be wider than 1.5 inches. We know that because these are 3/4 of an inch, they will be 1.5 inches, and you will probably want to measure those, just to be on the safe side, because typically lumber that comes from the lumber yard is not exactly what it is. I know that these are because these are actually face frame material. There's literally just a touch larger than 3/4 of an inch. So I have a little play there. If you can't get exactly 3/4 of an inch, you could double or triple up in some cases and then cut your pieces out of that. But they're literally just cutoffs. So what I would do at this point is I would take these and I would spread glue on those, put them back together, and then put them in a clamp. Several clamps across the top, and I'll show you what I got down below. Typically, I would make a bunch of these. Now, these came off. All of these came off of another project. All I did was cut them relatively close to the same size, and I cut them to fit, and I put them in a clamp. And we'll see what they look like here shortly. Once you fit, it's going to look like this, and they're pretty wide right now. Right now, they're just a touch over 1.5 inches this way, and literally 1 3/4 on this side. So I have some room to play here. A couple things to keep in mind. You want to make sure one edge is pretty flat. The best way to do that is put it on a dead flat surface and identify that this is the flat side. So I might just mark that as that's my reference point. I'll do that on all of these, make sure that they're relatively flat, because wood has a tendency to curl and cup even when you glue it. Check it and identify for flat and just kind of move forward. The next thing you have to do is you have to deal with the edges. We have to make one side absolutely square. And I'll go ahead and grab my square here. And I have to start at that point. Now, when you get this from the lumber yard, this edge may be square, it may not be square, but keep in mind you have all these glue marks to deal with. So I'm just going to kind of look and see what I got for square. That's not too bad, but there's still some undulations and so forth. So we need to clean this up. There's 2 ways to do this, okay? You can get some sandpaper and sand it, which is one possibility. or I can use what I have over here, and it's a joiner system. So we're going to use that first, but I'll also show you how to do it manually if you only have a table saw. So the first thing I want to do is get rid of all these glue marks. I could scrape it off, I could sand it off. It's just got to be relatively close. So we're going to do that first. Okay, let's go through the process of how to take care of squaring these up to 1.5 inch square. I have both the one that I've cut at the joiner, and I'm going to do that one first. Then I'll also sanded down this one here, and you see that this side is clear and this side still has glue on it. It's just because when I did it sanding, that's where it's at. So we're going to use that as a reference face. So let's go ahead and do the square one first. So now I have one square edge. Okay, so this is the bottom, this is the side, and so forth. I find the square edge, that's the one I'm going to reference off. The first thing I want to do is I want to cut off this glue marks right here, and I'm just going to bring it over. First, make sure your blade is up just above the wood line. You don't need to get it exposed higher or lower, just only what you need. Second, make sure it's absolutely sharp. You make sure that the blade itself is doing all the work. I'm not going to quite put this to 1.5 inches. You would think that you just want to go right to 1.5 inches and go from there. That's not what we want to do here. We actually want to go a little bit longer because we want to dial this in dead perfect. I'm going to let my table saw do the work, so there's no reason to try to cut it off in one big strand. Right now all I want to do is take off the glue marks. Let's go ahead and do that now. And 9/16. Okay, the reason I'm doing that is because if you take a look along this fence line, I've lost any gap that I've had, and that's perfect. We'll go ahead and cut that, and we'll also cut this at the same time. Set my fence to 1.5 inches. This is where I make my final cuts. Basically, I'm looking for the best face, and that's the one I'm going to put against the fence because I want to clean off the worst face, basically is what I'm doing. So I just kind of look at it. I also check for square, make sure that I have no issues in this one. I got a slight gap. I'm going to probably cut this face off. So that's where we're going to go next. Now you notice that I can actually do all 4 sides because this is just slightly wider than 1.5 inches, as well as this one, and this one literally right now is at 1 9/16. So we put that up against the fence with no gap, make our cuts. And with that, accurately tuned 90-degree cuts, both sides. And you tell us which one was done with a joiner and which one was done manually. I can't. So now that I've got my blocks and how I want to associate with them, I got to put the corners on as well as our front face. So I've already got a couple of pieces already cut. If you remember from our original video, these blocks are 1.5 inches, which you saw earlier, and then the difference between 24 and these blocks is what we're going to use for our facing piece. That actually comes out to 21 inches because my blocks are 1.5 inches square. 1.5 inches and 1.5 inches is 3 inches, so I have a 21-inch square. So I'm going to use that as a reference point. So I've cut a piece of plywood at 21.5 inches, which is fine. So what first thing we're going to do is we're going to place it up against our reference point on the sides. Second thing we're going to do is we're going to identify the blocks on the front and on the back. Now obviously we don't need a full height 16-inch block on either side, so we can use one of our other ones. Let me bring a couple of them out. So if you remember from the video, don't throw these little blocks away. These little blocks can be useful. In this case, a little 4-inch block works perfectly right here. So we're going to set that one in place. The next thing we need to do is we need to make a block on this side. So we'll find one that is relatively the same height. This one's got a little chip on the end, so we'll just reference that. So now, with that in place, I've got my piece where it needs to be. Okay? The next thing I'm going to check is how well this face sits against this face as it's sandwiched up. Now, if the sister module has been bowed out, that's going to cause a problem. You have to put that back into square. Sometimes you can do it with clamps, and sometimes it's not as easy. But remember, stress points on these joints are paramount to the success or failure of this particular system. But in this case, it looks pretty good. It's sitting by itself. There's very little gap. There's not really much to worry about. So what I'm going to do is I'm going to line this up where it's supposed to be. Line up the front, line up the back, and if for that purpose, this is actually a pretty good shape. Now what I'm going to do is, in order to get my sister, I'm going to trace the outline. And that is the outline that is traced. Now this is what I'm going to have to cut. Now keep in mind, there's two flat pieces. This one here and this one here. Okay? That corresponds to the upper portion of the sub-roadbed that I got here. So I'm going to have to remove that when I go through the process of cutting this out. And that's fine. It's very easy to do. All I have to do is take the difference, bring it back over, make sure it's parallel, and I should be just fine. Also keep in mind that this particular spur has an elevation on it. We're going to have to deal with that. So you may have to make a slight variance in your cut line, but that's you could do that with a wood rasp later. So the first thing I want to do is get this piece cut out, or at least aligned, so we're ready to go. So those two pieces are ready to go. So I've cut it out using the same techniques I used when I created the elevation ones. And the only thing that I really want to make sure of is that it lines up where it's supposed to. Now, it's a pretty good representation. There's a few differences here and there. Literally, if you wanted to, you can clamp these two together. Take a drill. And sand them perfectly. It doesn't matter that much because scenery material is going to go on it anyway, but for right now, we're in a pretty good spot. So that's our first cut where it should be. The next thing we need to do is to mark for our legs and mark for our joinery. On our last systems, we use these little guys. These are our dominoes, and we're going to use them in the same spot here. So let's go ahead and finish up these two legs, get them and clamp them in place, and then we can move on and start moving towards the rest of the module. Let's do that next. Okay, with my joinery and my dominoes in place, I'm ready to start making a connection to my next system. And it actually works out pretty well. Now what I can do is I can start the process of doing my next front and back board. Let me get a couple of them out here. The ones I've marked already are down below. And that's what these are. So what I've done is I've taken the time to mark the front of them, and I'm going to reset the camera so you can see what's going on. Okay, I've set up the module before I've actually made some final marks on my other side, because I wanted to stop here and show you how I go about identifying what I want to do. So right now I'm only viewing the front of the module. Okay, so in that the viewpoint is directly in front of it, just like you're looking down the track. It's directly in front of it. I came across this black line, which is where I first started, and I thought this was a little bit too high, so I'm going to modify it a little bit. And that's okay. You have the time to do it now. Make the adjustments as you need to. A couple things to keep in mind here. First of all, how it's going to be viewed is not directly from the front at all times. It's going to be viewed from a variety of angles. So the first angle that I would have would be the angle from this direction here. What do I want to see and how do I want to see it? So I know there's going to be a couple of tunnels here. There's going to be a rock face towards the top. It's going to shade down slightly toward the back, but it's going to be taller on the back and be smaller in the front, which is exactly what I want. So that's the first thing. I'm going to see my angles this way. I'm also going to see angles this way, and basically I'm viewing the curvature of this towards the back, which is going to be higher. The last thing I want to look at is literally from the other side. So what is the other side going to look like? So I know that the tunnel comes out, there's another one up at the top. How do I want that to view? That's going to help me determine how I want to draw this. Now, I also know that somewhere down in here, there's going to be a culvert lower than the track line. Okay, possibly a creek or something that comes down. It's actually going to be lower than the track line, which is something I literally want to do. If you're in the Pacific Northwest, you're in Colorado, Montana, things of that nature, it's not uncommon to go below the track line quite extensively. So this is kind of what I want to do. So I'm going to kind of bring it down below the track line, staying above what I call my 1/3 line, and my 1/3 line is literally at 1 1/4 inches. Bring it back up, back to 4. That's where I'm going to go from there. So let's talk about span strength and when you're cutting your scenery into the side of a module or a permanent layout lower than the track line, for a river or gully or any type of culvert. We talked about span strength in the first video. The longer something is, the more support it's going to need in order to maintain its strength through the entire span. So in this case, I've actually shown a couple of things here. First off, I've shown how tall this particular piece is, and I've shown what is called the 1/3 line, and we'll understand about what that is in a second. If I press down on this, I'm really getting no deflection from the wood because it's vertical. It gets most of its strength from a vertical. My support is on the outside. So what happens when I start cutting into the wood? Obviously the support along the span is going to be littler and smaller. So we don't want to go below that 1/3 line. We'll see why that is in a second. So let's go ahead and cut a small culvert in here and show you what happens in deflection at different points along this way. Okay, so I've cut a small indentation around the side of this particular piece. And it's not quite at the 1/3 line, but it's enough to demonstrate what's going on here. So first and foremost, when we go through this process, we need to understand that now our span strength has to go, instead of 3 inches, it's going to go just about 2 inches. So if I press down on this, right now there's no deflection of this from end to end. And that's important. We don't want any deflection. We don't want the supportability. Remember, your support for most modules is on the outside. It's also getting pulled in 2 different directions. Plus the force of gravity is pointing it down. So a lot of the weight's coming right here, and as it comes right there, this is the central point of failure. So we need to make sure that we support this. So right now, even where it's at, it's not deflecting at all. I'm putting quite a bit of pressure on it and it's not deflecting. Let's go beyond that and see what happens. Okay, at this point, as you can see, I've gone below the 1/3 line, and that's kind of important. Right now, as it sits on the table, there's not enough weight to actually do anything to it. It's below the 1/3 line. It's not really a lot of span from this particular distance, but you may have a series where it's actually lower than the track line for quite some distance. You'll have to deal with that span. Now, if I put a little pressure on this, you can see that the wood is starting to deflect. Not a lot, but it's enough to be concerning. Let me tell you why. First and foremost, most of the support for all modules is going to be on the outside. Okay? So with that being said, your weakest deflection point is this little piece right here. That's really not enough to support what we're trying to do. And this is only one side. Remember, you also have scenery, track, and everything, plus anything with the ribs on the inside is also forcing this down. So you have two possible options here. One, you can have support closer to where the culvert is. That way the span is a lot less, and you can see there's really no deflection. So we have to take that into consideration. If you don't have that option where your support is on the outside, you can actually do a couple of ribs that are relatively close to that culvert. What this gives you is a little support on the inside, and it gives you the ability to have ribs not only here but also here that supports this. So the strength of this particular rib and the strength of the other rib will actually support that. Just keep that in mind as you go through the process, and we're going to do something similar to that on our module here. All in all, if you get too much, and we're going to cut this a little bit again to show you exactly what happens when you go too far. Stay tuned for that. Now, I've cut even more off, and I've also increased my span where with the weakest amount of material, and it's literally probably maybe 3/4 of an inch. Now, if my support is still on the outsides, if you take a look, I could put quite a bit of pressure on this, and it is bending substantially. And that's not a lot of pressure, that's just enough to where I'm going to put my arm on it. So imagine, if you will, most modules are between 15 and 20 pounds by themselves. Any scenery material that's on the top, anybody leaning on it, any force that's coming from the side, you literally can have anywhere between 25 to 35 pounds on this particular joint as it is. In this case, I don't think I would trust it by itself. I would actually have to reinforce it in a couple of spots. And there's a couple ways we can do that. The ribs is probably the way that I would go. The other way that you can support this is, if you don't have the ability, is you could set it on a tabletop. Obviously with a tabletop, it's not going to go anywhere. So if you have that ability to put it on a tabletop, you could go literally as low as you want, but I don't think I'd go anything less than a third anyway. So as we move through this, I have to keep that in mind before I cut out my final pieces. Remember, I'm going from a tall piece actually down below the track line and back up again. So there's going to be a lot of weight for that particular piece. So I'm not going to go below that 2/3. So this is where I am with my terrain arrangement in this particular module set. It's going to start out at 4 inches. I've changed my mind a little bit to have a little more down facing on this side versus the other line. Brought it up to about a 12-inch span, and then it goes down abruptly below the track line again and then back up to where it needs to be. Now, you'll see that I've created a support here, and I've created a support here at this 12-inch mark. That support is literally we're going to create our first 2 tunnels, and we'll show you about that once we get to the track plan. It's then going to come across the center of the module where they meet, and then it's going to drop sharply below the track line. And this span literally it's going to take it down to 2.5-inch mark, but it's going to be kind of moving up from there. So I put a support on either side of it that will give me the support that I need, which is greater than the 1/3 that it's going to be. So I'm not going to have any issues with it deflecting or crushing around in the center. However, before I start cutting this all up, there's one thing I need to do from the last module that I needed to drag over. Let me set that up and show you. Okay, before I get too deep in it, or before I start cutting any of this material, there's a couple of things and a couple of conditions I need to account for before I move forward. I can't just cut this and cut the other side. I have to deal with these 2 pieces here, which is the second of our conditions. We have to deal with the elevation of our track line at this point. Typically in the woodworking arena, it's called a storyboard or a story stick. In this case, I put the story stick literally on the module itself. It'll be painted over later. Now, if you remember, the elevation is still going up there, and I have to account for that. So I'm going to draw that elevation and basically then come back to the center. So here's the first thing we're going to do. We're actually going to take our rule and we're going to generate the lines on either side. Let me go ahead and do that now. So that's the first one. The second one, instead of trying to figure out all the math on it, I'm just going to use the ruler again. I have a 24-inch ruler. You can use any straight edge you want. The ruler seems to work out pretty well. All I'm going to do is I'm going to line it up about a foot in and then just drag it on over. Redo that. Now, I'm able to capture elevation in each one of these because this is already identical. Now, if I wanted to, and this is what I'm going to do, I can continue this elevation all the way across the top. But I'm going to stop literally behind this spot here and basically go back to elevation 0. What I mean by elevation 0 is that it comes back to go to level. All I need to do is follow along with my ruler to where I think it needs to be. And as long as I cross that point there, what I need to figure out is my elevation going from this way. And all I'm going to do is measure from here to here and then from the other side and just bring up my access point, which will probably be somewhere right there. Use the same techniques for a rise as you do for a leveling out or a decline. All I need to do is account for that, and then I'm right back where I need to be. Okay, I've gone through the process of cutting all my holes, so let's take a look, see what it looks like. So now that we have our front contour actually done, I'm going to save this piece here. So I'm actually going to use this over in this section here. So I didn't want to cut the other ones until I was ready to do it. So there's no point in cutting a brand new board because I could actually use that one there. Now what I need to do is I need to cut my center sections just like I did on the first one. I wasn't going to cut them until I know exactly what height I'm going to need to. So it's actually going to kind of contour down from here. Now I could use one or I could use two. It's completely up to you. I'm going to use two here because I want to have the opportunity to have legs in here like we seen from our first videos. We could put the 1.5 inch legs in between and that'll work out just fine. My next thing to identify once I get to that point is identify the ribs that are located here and the one that's located here, as well as the two located here and here. Those are going to have contours that are going to be really high and then come down pretty low, as well as inside here. That'll determine what my last one's going to look like. Same thing holds true here. Now, we have our topography for our spur line. We also have our topography for our main lines. I'm going to use the same techniques by identifying the sizes to cut those, but I'm not going to do that first. The first thing I want to do is get all these ribs in place. So the next time you see that, I'll start with the ribs.
Okay, let's get started on identifying how tall and how wide we need to make the hole for our tunnels. This represents the bottom of the top of the module where actually the sub-roadbed sits on, and that's just a given or a plate that we can use to get our reference points. The first thing that we need to account for literally is our sub-roadbed, and that represents the same exact height as what's there. So I'm just going to lay that flat here. The next thing we have to account for is any, for example, cork roadbed that we're going to use. And most cork roadbeds anywhere between 3/16 to a quarter of an inch. This happens to be 3/16. The final thing that needs to go down from a permanent standpoint is literally track. If I put all this together and I measure it out from top to bottom, I'm literally just over 7/8 of an inch. And that's okay, so that's a good starting point. So you're going to have to count for 7/8 of an inch just to start. The next thing I need to do is I need to account for the height of a car. So I brought out the largest car that I had, or the tallest car I should say. I'm just going to stick it on the rails. It doesn't have to be on there perfectly, but just so that it doesn't move. And that's good. Now, if I take a rule and I'm going to sit it down on the flat side, literally at this point, I know that I'm at least 3.5 inches from this point. So I'm just going to take a different rule and go a little bit further. I'm going to measure it out from the top to the car. And I get 3 5/8 inches. You always want to round up possibly a 1/4 inch just to make sure that you have enough space. So I'm going to go literally to 4 inches, and that's my benchmark, so it's 4 inches. The next thing I have to deal with is I need to deal with how wide it happens to be. In this case, if I have a single track, all you have to do is make sure that it's at least a 1/2 inch wider than this setting. So if my sub-roadbed is 5 inches, which is what this is, and the other one, which is 2.5 inches, I just need to make sure that when I'm going to put it on, I have a 1/4 inch on either side. That's to account for two things. The first one is if you have any overhang from the cars around this turn, or if the car's overhang is so severe that you actually have to move the tunnel portal in order to do that. In some cases you have to do it, especially with the 72-foot passenger cars or the long 89-foot flat cars. All of those typically have a lot of overhang, so you need to account for that. But for the most part, we can get started on our next piece, which is cutting an original hole, and I'll show you how to do that. But first we need to mark out 4 inches by whatever the size of this is, plus 1/4 inch. That's what we'll do next.
Now you might think that you want to identify a center point and measure from there, but I'm going to do it a little bit differently. The reason being is because you can't guarantee measurement points from your modules or wherever you're going to put this. So literally all I want to do is identify where I'm going to start. And in this case, I just mark the outsides of where I'm actually going to cut my hole. And I'm going to work from that. So that's my reference point. The first thing I'm going to do is measure 1/4 inch from each side. And I'm going to strike a line at a 90-degree angle. And I'm going to do that for 4 inches. And literally that's what I'm going to cut out. So I'll do that next, and we'll show you what to do from there. Okay, so I finally cut out my hole the way that I wanted to. A couple things we need to do, and I'm going to show you actually up on the module itself. So let's say this is our rib or our sub-roadbed that is currently in place. The easiest thing that has to do is all we need to do is to align it to the top, center it, and I'm going to get this out of the way temporarily. Now, how do you secure it to the top? Well, the easiest way to do it is with a scrap stick, maybe a scrap piece. Make sure that you have enough on both edges. Put a couple of screws and some glue in, and that's really all you need to do. Very simple to do. And then from there, all you need to do is draw your terrain. A couple things to keep in mind here. Make sure that this width is actually 1/4 inch on either, up to 1/4 inch on either side of the opening to make sure that you have a little bit of playroom. And also make sure that what it's sitting on is flat. Okay, I've clamped the two boards together on my flat surface, and I've literally put these little ribs inside here, and they're actually screwed and glued in place, and that'll hold it for what I need it to do. Now if I turn it around, you can't really tell that this actually was cut into 2 pieces. Now, what I gotta do, since this is all gonna be hidden, I need to actually cut my terrain out where it needs to be. I've also taken the time to cut this line here, and this is my 4-inch track line that we saw from the front. Our tunnel doesn't start here for these lines, it starts a little bit further back. But for the first one, it starts a little bit earlier, so I've actually gone through that process. Now I can get it in the module and actually determine where the final cuts are going to be for the terrain. And that's what we're going to do next. So let me put this together and go from there. Okay, this is rib number 2 inside our module set. I'm going to show you a couple of things here. Using the same techniques as I did with our riser module, I've calculated the track height in both locations. Keep in mind that I still have this track is still on, going up on an elevation. The next thing I did is I measured off 1/4 inch from each side of the track from where it is, and I've drawn up 4 inches. So this is the hole that I'm actually going to cut out. The same thing holds true here. The key to this system is actually when it sits the reference line on the module. If you remember, on the front of our module we have our little storyboard which tells us how high off the side or from the bottom that we're going. This one is 4 inches. This one actually is 5 3/4 inches, which is what it's actually going to be. From here it goes straight on and the elevation flattens out. But from here forward it actually goes down. And that's fine. So now what I need to do is I need to cut out these holes. There's a real easy way to do that without tearing it out. Let me show you how I go about doing that. First thing I'm going to do is I'm going to clamp it. First thing I do is clamp it to the end or some type of table. And my table saw does pretty good for this. So all I want to do is to keep it from moving around. Now what I'm going to do is I'm going to drill on both ends, or kitty corner to each other. It doesn't matter one side or the other, and that's fine. But I want to stay inside the lines, and that's easy to do. Jigsaw, saber saw it might be called, with a very fine blade as well as a very maneuverable blade. Stick it inside the holes and just follow the line. Keep in mind you want to take extra precaution and stay as perfect as you can on the track side, because remember our sub-road bed sits on it. If it's a little off, it's not going to be too bad, but just make sure that it doesn't deflect or something, deflect or change the angle in any way. We'll show you how to deal with that in case that happens. So let's go ahead and cut. We're ready to go. So we have all the pieces for our module and separated out here. Here's all the cross members. Here's our posts or our corner pieces. And there's a bunch of pieces over here. This is actually cutouts. This is extra weight we didn't need in the pieces. And there's some cutting holes, different sizes, and in some cases we just cut strips out where we didn't need to. All this adds up to about 5 or 5.5 pounds. That's just extra weight you don't need to carry around. So the next thing we do is that you can see where I've actually taken weight out. I've cut holes in various spots. I've taken out the bottom, which we don't need to worry about. It doesn't take away from the strength of the piece, but it makes it a lot lighter. This is probably maybe a pound lighter than it was earlier, so it's pretty light. So now what we need to do is go ahead and assemble this, and then we can glue and screw it all together, and then we can deal with the next part of it is putting on our ribs and finally our sub-road bed. That's what we're going to do next. Okay, we got the module all put together. It's all glued up, it's all screwed up. All the ribs are actually in place and are all very solid. As you can see, the holes have been dug out and it has its first sanding. I've adjusted it accordingly in a couple of spots and just resanded. I may have to touch that up later. Now what we need to do is we need to go ahead and put down our sub-roadbed. I cut a couple of pieces a little bit longer than what I need, and this is pretty much a straight shot. But if you remember, there's going to be an elevation change here. So just like we did with our riser module, I have to cut a relief inside this particular sub-roadbed so that I can go down a lot easier. Once that's done, we'll screw everything in place, shave off the ends. Okay, so we finally finished up our module here. We've actually installed the sub-roadbed, and we sanded down the sides so that they're actually flush with the end piece here. And we'll see why that's important in just a second. I've actually gone through the process of making sure all of my alignment is good, the screws are all tight, everything is where it needs to be. Now it comes time where we need to connect our sister module to it. And we're going to talk a couple of things about connection points. First of all, you're probably used to seeing these when you're connecting modules together. These are actually used to grip them together, and friction is what holds both the alignment in place as well as the connection to itself. I'm going to opt away from these. I don't like these in the first place. You only have one small structure point, and it really damages the wood, especially if the wood is out of square or if the wood is actually warped. I'm going to use locating pins. They're actually located inside there already. And those locating pins, there is a male and a female. And what I use to make sure that they're aligned is once the system is aligned, I use a template. And this template is designed to screw 4 holes on the side. So the 4 holes can be used whether it's a 6-inch, an 8-inch, a 4-inch, it doesn't matter. So once I reference that, the 2 inner holes are used for the alignment pins, the 2 outer holes are used for the second mechanical fastener. And we'll show you that here in a second. So what we do is we put it on here, we drill the holes, and we line it, we drill the holes, and we're good to go. Now once the holes are aligned, the next thing we need to do is we need to pull this thing together. Again, staying away from these. If you can stay away from these, you're going to be a whole lot better in the long run. You're not going to damage the wood as much. You're not going to try to keep everything in the square. The alignment pins will do that. This is actually a 5-star knob. Literally $4 or $5 at the hardware store. And this is a T-nut. I've opted to the ones with the holes in it because the ones with the prongs in it, it's very hard to get a hammer inside here to beat that in place. So I've opted the ones with the holes, and I think the screws hold better. Even if it does move, I can just turn it 90 degrees and put the holes back in. It'll be just fine. Now what I do is I take it and put it through that hole on either side and actually pull it together. We're going to do that now. Let me get this, save these 2 for later. So once I align my module, put the locating pins in, and you'll see that every time I pull it apart and put it back together, it goes in the exact same place. All I need to do now is take my 5-star knob, put it through. And normally I do this on its face or flip it up on its back, but seeing as how this is just demonstration, we'll just bring it together. Lock it together, and you can see it pulls it nice and tight. Now, normally if I had a 4-inch module like I did in the starting front, I only need 2. But seeing as I had the extra height there, I added a third hole with a 5-star knob. And we'll see why that's important here in a second. So I clamp that one together, clamp this one together, and I'm going to bring my cell phone out here in a second. We'll show you how tight this actual connection is. And there's a reason for this. So now, it's connected, and literally it's like it's one piece. And I can lift up one side and the whole thing comes up like it does normally, and that's fine. But since I have this thing nice and tight, I'm not going to need a knee for those 3-inch pieces. Those locating pins assure me that every time I put this together, it goes back in the same spot. Now let's take a look at the strength of this. I've actually locked down these just hand tight. They're nothing more, the locating pins are in place. I'm going to move on to the end here and actually lift up on the entire structure all the way to the end. And as you can see, across the entire 8 feet, there's very little to no deflection across the 8 feet. I could see down the side here, and maybe there's a 1/16 to 3/32 of an inch deflection from the front. That's pretty strong to begin with. Also, if you look at it, I can lift the whole thing up at one time on either face. 2 guys can actually flip this around like a baseball bat. It's very light, it's very strong. So when working from this side, this is about a 19-pound. This one is about a 13-pound. And the difference is actually in the weight of the wood more so than anything else. Now, I'm going to bring it out to the end to show you the linear strength of this. And let me go ahead and move the camera here. So as you can see, the front is still on the table, but the other side is literally 7/8 inch off the end of the table, and there's no deflection whatsoever. I can even put a little weight on it, and I have more of a balance issue than it would be as far as the thing holding up versus the connections coming apart. So we're going to tell you that's extremely strong. The only thing I need to do now is we're going to call this module done from a woodworking point of view, or from a fabrication point of view. Now we can put on our track, our roadbed, our track. We can start cutting our holes for our wiring, as well as we could start our scenery. But that's another clinic. So until that time, we're going to call this part done, and I can start working on the next one. The next one, I just do the same process as I did before. I create my story stick in the front, and I just keep moving down the line. So until next time, we're going to call this finished.
Oh, that was such an interesting video. Now I know I have a module to build, so I have a pretty good idea how I'm going to build it. That was very good, Jeff.
Appreciate it.
I do have a bunch of questions, though.
Okay.
We'll start with a simple one. Why do you not use solid timber? I know it's plywood, but why not? I don't know, pine, oak.
One of the problems is whenever you go to the big box stores or even to your lumber mill, it's very difficult finding the lumber that has the same consistency all the way through. A lot of times, if you're going to be using, for example, want to make 1x4s, you'll have to mill it down to get to the exact size or frame that you want. Also, many of the timbers are going to be twisted or even warped in some cases, and you have to go through the extra process of milling them down. Using plywood means that I can get more stable material at a lower cost per linear foot than I could for solid material, and it's actually stronger.
That's nice to know. Another question was, yeah, I have the same question. I didn't see any screws. Is everything only glued, or is everything nailed, or like how is everything pulled together?
So short of pocket screws, and the pocket screws are only used as clamps, there's no other screws in the system. The entire framework is actually screwed from the inside out, which means that you get a better visual point. Also, screws don't have a tendency to pull out over time. As modules get moved around, those screws tend to loosen and eventually fall out. So I don't use them as much as as much as other people do. I only use screws as clamps. The glue does the 90% of the work.
Oh, makes sense. Another question. Do you paint or seal your modules?
I always paint them even before I do any of the track work and so forth. Wood, like most materials, is still sort of a living mechanism. If you don't protect it, the moisture content that gets into the woods and temperature humidity has the tendency to expand and contract. And literally that's what warps modules. So you want to protect the wood even before you do your scenery work. When I started these here, once the woodworking was done, they were completely painted black, and then the scenery work started. So because you're going to be introducing moisture from a scenery perspective, you want to seal and protect the wood as much as possible.
Okay, you brought up a point where I've got a personal question where I've got a problem with humidity. So doing it this way, I wouldn't have any problems at all.
No, the problems will be mitigated because you're putting a barrier protection against the wood fibers. Most of the moisture will be wicked away or don't even enter the wood as a whole. Since you're sealing those pores, it's like when you were a teenager, you're sealing the pores, you're always washing the dirt out. You don't no longer get pimples as you get older because that'll mitigate pretty much all of that.
Okay. Also, I noticed the ease that you have lifting up those modules. So I was just wondering, how much weight does one module weigh?
Well, let me kind of give you an example. So this is a basic module by itself, and it only weighs about 8 pounds, and it's made out of the same material. Obviously, the more height that you have in it is the more weight it's going to be. So I'm going to bring the camera down and kind of show you where these modules that you saw in the video are now. So this is the tunnels and culverts module that you saw earlier, and it's already begun its detailed process for scenery. And this is the left-hand side, and I will try to keep the camera as simple as possible. And as it kind of creeps up and over, this is the culvert side, which you saw earlier. And that culvert side also has most of the detail work. There's still some color work that's left to be done, and I'll try to get an upper shot here. So the culvert work needs to be done still, as well as some of the work around some of the detail work. So that's the one that we worked on earlier. The opposite side, the risers and corner module, which is this one here. So it literally is the sister module to that. It's also receiving its detail work as well. So that's kind of where we're at in the process as of right now. And there's a third module, which is literally back here. I'm not going to go back that far, but that third module already is receiving its detail work as we speak. There's a little bit of electrical work left to do, but for the most part, these modules are pretty much done. They were started, the first one was started in February, the second one started in the latter part of April, and now in August, they're nearing completion. So a lot of work over the last 6 months.
I presume you must move those modules pretty often. And
Oh yeah.
so by having all those pieces glued, do you have any problems at all, pieces being unglued, or like, I don't know, with humidity or
No, actually, I'm actually, if you really wanted to do them, and just even, I could spin them around here with no issues. They're that strong. I can lean on them. They're very, very strong. So they're very light, and the techniques that we use to build them with the dominoes, as well as the construction techniques and the modern day glues, they're extremely strong. You'll break the wood before you break the joints.
Another question would be, how do you do curves with that?
So you can do curves. There's a way to actually use thinner strips of plywood, and you can bend them around to form and actually wet them. And as they dry, they maintain their form with the glues and so forth. You just need to create a template pattern in order to go around those curved structures. The rest of the joinery works the same way. So if you wanted to go, let's say 90 degrees from, in a nice curve, I just get thinner strips of plywood, apply glue between them, bend them around the form, and then once it holds its shape, cut them to fit, and then they fit inside their joinery like they would anything else. It works well. I've used that process before. It works great.
Definitely, it's very interesting. Now I'm anxious to start my little module that I want to build. And if I have any questions, I'll definitely check you out.
I'm always available. You can find me on Facebook. I have a Yahoo address. I mean, I answer all day long. And obviously, I have the technology to kind of show you guys what I need to do. So if need be, just get a hold of me. We'll go from there.
Okay. So I guess we're coming at the top of the hour. I don't see any other questions right now. Let me just check. This is YouTube. Let's say Facebook. No, that's about it. Yep.
Sounds good.
We're good.
Okay, before you go, Lloyd, I'll just jump in and do a quick announcement. Jeff's going to come over, hopefully, to the breakout rooms. He's got a little group there. I've seen some people dropping in and then dropping out, being as you're not there at the moment. So I think there are a few people out there wanting to catch up with you, and probably got a few more questions. Yeah, I see a few more people dropping in now. So, yeah, I'll hand it back to Lloyd to finish up. And then when you finish, Jeff, head over to wearby.com/MRL-Aussies. And there'll be, there's people in your room already waiting for you to get there. So I'll let Lloyd wrap it up, and I'll be back later on.
Okay, Marty, thanks. Yeah, so don't forget to check out the breakout rooms. Very interesting way of chatting with the people doing the clinics. So thank you very much, Jeff, and we should see you again soon.
Sure thing. I'm already working on the next clinic.
Okay.
Hey, I'm DeBob from DeBob's N-Scale Man Cave, and you are watching the NMRA X YouTube channel. And if you have not subscribed down below, ring that bell, and give it a good like as well. Leave a comment down below, but by all means, subscribe. I know you want to. And by the way, you should stay off those tracks. Thanks.